Welcome to my video. I am Dr. J. Prakash, Associate Professor, Department of Computer Science and Engineering, Hindustan College of Engineering and Technology. In this video, you are going to learn about finite state machine, types of finite state machine, representation of finite state machine, and the difference between finite state machines. A sequential logic unit which takes an input and a current state produces an output and a new state. It is called finite state machine because it can have at most a finite number of states. It is composed of a combinational logic unit and flip-flops placed in such a way as to maintain the state information. The diagram shows that the input and output of the finite state machine. A pointer will controls the finite state machine. Representation of finite state machine are two types. One is state transition table, another one is state transition diagram. State transition table is a representation in the form of table. It consists of current state, input, any output, and the next state. The state transition diagram, it also represented using a state diagram which has the same information as the state transition diagram. The next is the basic definition of finite state machine. It is a mathematical model consists of 5 tuples. Those are capital Q, a finite set of states, summation, a finite set of input symbols, also called as alphabet. Alphabets are 4 types. Those are digits 0 to 9, special characters, operators, and symbols that are given in your keyboard. In simple terms, if you want to remember all the characters that present in your keyboard is a input for the finite state machine. Q0 is a starting state, F set of final states, delta transition function which is a mapping between set of states and input alphabets goes moving to more number of states. A DFA is defined by 5 tuples, capital Q, summation, starting state, final state, and transition function. Types of finite automata. Two types of finite automata, both described, which are called regular languages. Deterministic finite automata, there is a fixed number of states, can only be in one state at a time. Non-deterministic finite automata, represented by NFA, there is a fixed number of states which can be used for traveling more than one state. How to use DFA? Input a word or a character can be given to the finite state machine. Is W acceptable by DFA? Start at the starting state Q0. For each and every input in the sequence W, we do compute the next state from the current state, give the current input symbol in W and the transition function. If after all symbols W are consumed, the current state is one of the final state and then accept, otherwise reject. The next is extended transition function, how the finite automata travels from one state to another. Transaction of Q0, W equal to ending state of the path taken from Q0 on the input string W. The representation is delta, it is mathematical representation. Here we call it as transition function. Transaction of Q0, W, A, W is an input string and A is another string, equal to transaction of Q0, W, A. This is how we will represent extended transition function. The basic definition of NFA, non-deterministic finite automata, it consists of 5 tuples. Those are capital Q, a finite set of state, summation, a finite set of input symbols called alphabet, Q0 starting state, Q, a final state, delta transition function. A DFA is defined by 5, NFA is defined by 5 tuples as well as DFA defined by the same 5 tuples. How to use NDFA? A word W is input string. If W accepted by NDFA, start from state Q0. For every input symbol in the sequence W, we do determine all possible next state. That's very important. In DFA, we will go from one state to another state. For example, input A will travel from Q0 to QF. That is only possibilities. In DFA, Q0 from Q0, A can travel to more than one state, Q0 to Q1, Q0 to Q2, like that it can travel. That is the main difference between NFA and DFA. If after all symbols in W are consumed, at least one of the current state is a final state, then accept, otherwise reject. Extension of transition function to NFA path. Basic transaction of q comma epsilon goes to q. That means each and every state within itself has a same transition function. Epsilon transition means empty transaction that is possible in all states that are present in NFA. The difference between DFA with NFA. DFA, all transactions are deterministic. Each transaction leads to exactly one state. NFA, transaction could be non-deterministic. A transaction leads to subset states. For DFA, for each state, transaction and all possible symbols should be defined. In NFA, for each state, not all symbols necessarily have to be defined in the transition function. In DFA, accept input if at least one state is F, final state, except if one of the last state is final state. Sometimes harder to construct because of the number of states in DFA. Generally easier than DFA to construct in NFA. In DFA, practical implementation is feasible. In NFA, practical implementation has deterministic, so needs to convert to DFA. Thank you for watching my video. Have a great day.